Welcome back. This is going to be for FOM 11, chapter 5.1. So this is just the introduction to statistics. But before we begin, I guess we need to go over a couple of definitions. So the first definition is the word mean. It says here it's denoted as what looks like an X and a little bar on top of it. So it's referring to a sample, or this crazy upside down or looks like a little weird U, it's pronounced mu. So it's referring to an entire population. So X bar is the what's called the average for a sample, and mu is the average for a population. And it's calculated by adding up all of the data items and dividing by the number of items. So I'll just do a quick example. So if you had a score of, let's say, 22, 22, and then a 26, what is your average? Well, then you would use your calculator. Let me just shrink that up. So it would be 22 plus 22 plus 26, and because there's 3 tests, we would divide by 3. Oops. It should be brackets. So I'm going to go 22 plus 22 plus 26. All of that added and then divided by 3. So your average is 23.333. So X bar, if this was your sample, would be 23.33. If this was your whole population, then your average mu was 23.33. Next thing is the median. It says when data is organized from smallest to largest, and that's the key. The middle value is the median. So if I gave you some values, notice that's 22, 22, and then 26. The median is whatever middle value it is. So that's the median. Now, another example is if you had a 22, a 22, and then let's say a 26, and then a 40. Those are just 4 tests. Well, there isn't really a middle value because this is an even set of numbers. So the middle value then would be the number in between 22 and 26. So how do we find this middle number? Oh, well, it's going to be 22 plus 26 divided by 2. So then the median becomes the number 24. Yes, the number 24 isn't actually part of the data set, but it is the middle value in a set of 4 numbers. Okay. Now, mode. Mode is the most frequent item in a data set. So here we have 22, 22, and 26. That was our original data set. Well, the mode is a number that appears the most. And in this case, 22 appears the most. So this is the mode. So that's just a quick definition of mean, median, mode, which are measures of what's called central tendency. And these 3 terms, all they really do is describe a particular data set. And each one has pros and cons. Okay? Moving on in our notes, this thing called an outlier. An outlier is a value in the data set that is very different from any other values in the set. So back to our example, 22, 22, 26. So on average, it looks like you're in the 20s if you're getting score values of that, and then all of a sudden, let's say you had a really bad day and you got like a 4 on a test. Well, this would be considered an outlier because it doesn't look consistent to the other scores. Okay? The next definition is what's called dispersion, a measure of how data is spread in a set. So a way to describe dispersion is range. So let's take a look at this particular set of values. It says, what's the difference between the highest and lowest data values? Well, the difference between the highest and lowest, well, the highest is 26, the lowest is 4, and it says the difference between the highest and lowest, well, that would then be, difference means subtraction, so that would be a a range of 22 points. Okay? So all I did was I subtracted, and I apologize for my handwriting. Now, a line plot is a graph that records each data value in a data set as a point above a number line. I'm going to show you that at a later date. Okay? So just moving ahead, here is an example. It says here The payroll for 3 small companies are shown in the table. So we have, we have one that's called Media Focus Advertising, one we have Computer Rescue, and we have Auto Sales. What we want to do is we want to find the means, the ranges, the modes, etc. Okay, so what I'm going to do is I'm going to show you a website that you can use. It's called calculator.net. So there's a series of math calculators. I'm going to hit what's called the standard deviation calculator. And all the standard deviation calculator, we have what's called a probability calculator, a sample size calculator, and statistics calculator. I want you to hit statistics calculator. And here looks like the actual keypad to a calculator. I don't want you to waste your time doing that. Instead, what you could do is you can literally just add the values in. So what I'm going to do is I'll do the very first example. So once on this statistics calculator site, what we can do is we can use this website to calculate mean, median, and mode. The best way to do it is literally type in the values. So it's 245,000, comma, 162,000, comma, and I'm going to put the video on hold because I don't want to waste time you watching me type this all in. So now that I have typed them all in, I'm ready to hit calculate, and the website should give me all the information I need. So first things first is I notice that there is what looks like a count of 15. So let's just double check that I've actually counted 15 or inputted 15 values. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The worst thing you want to do on a test or a homework assignment is, of course, miscount or mistype the number of data points that you want to enter. So it looks like I've done all of them. Now, as I go through my notes, there are some screenshots of calculator that unfortunately we don't have a class set of, and you probably don't have access to. So in the meantime, I suggest you go on to calculator.net and use that site to help you calculate. So I'm going to go down to the bottom here. It says determine the mean, median, and modes and range for these companies. Well, our website doesn't actually give us, well, it does actually, largest and smallest. It gives us the range. So let me just do that. So let's just write for the very first column. The mean is, of course, what looks like 7886.7. Again, apologize for my handwriting. Median is 57,500. Mode is 61,000. And what looks like the range is 21,770. What I want to do is I want to give you a chance to try the other 3 out using the website. In the meantime, what I'm going to do is I'm just going to give you the values that I have in my notes, and please, if you see any errors in the other columns, please do let me know. So the second company, I think I have in my notes, the mean is 86,013, median is 59,000, mode is 96,500, and the range is 30,970. And I hope that's right, because I can't even read my own handwriting. Okay, so the mean for the last company is 62,480. The median is 58,900. The mode is 55,250. And the range is 42250. Now part B says, which measure of central tendency best describes the average salaries here? So when you take a look, the average salary, we want to know which particular set of data describes the average salary. It says, which measure of central tendency best describes the average salaries here? So if you were to take a look at the data, you have a couple of people on the high end of salaries, and then you got a whole bunch of ones in the middle, and some people that aren't getting paid very well for the very first company. The second company, you've got a couple of people on the very high end. It looks like, you know, for company number 2, Computer Rescue, look at how everyone's around the 50, 60,000 range, or most of them are. And then auto sales, hey, there isn't somebody that's getting paid outrageously high. And again, a lot of these people are getting more or less the same. So when you take a look, all right, when you take a look, it says here, which measure of central tendency best describes the average salary? So for the first company, is the average salary roughly 70,000? Is it roughly 57,000? Or is it roughly 61,000? Well, for company one, hopefully you would agree, company number one, oops, hopefully you would agree that there is a couple of people that are making crazy amounts of money, and that brings up the average. And so the average looks like everyone on average is making 70,000, but if you take a look at the data, most of them are actually around here. So company number one, the average salaries could probably be best described by medium and mode. Okay. Now company number two, well, they don't make us the people that make on the high end, they're not super duper high. So company number two probably can be best described by the median value. Company number three, well, company number three, again, mostly everyone makes roughly the same thing, so median again best describes the measure of central tendency, which means the average. Okay. Question C says, which company have data that appears to be outliers, and which measures of central tendency are most affected by these? So outliers are the ones that sort of drag the numbers really, really high or drag the numbers really, really low. I would have to say that company number one has a couple of outliers, and the outliers in company number one are the people that make crazy amounts of money, whereas everyone else doesn't. And so in reality, these two people make it look like everyone's at, making $70,000, but you can see truly they're not, right? And it's because these two individuals make so much money they pull the average up. So the outliers are probably company number one. Company number one. Now, when you have crazy outliers, what does that tend to skew, or what does it tend to sort of misrepresent? Well, it tends to misrepresent the mean, because it makes it appear that the average salary of company number one is very high, when in fact, when you take a look at the data, most of them aren't making very much money at all. All right, example number two says, consider the measured lifespan of two different brands of cars of battery. So you have brand X and then brand Y. You're going to use the website again. What I'll do is I'm going to clear the data. And before I actually start entering it in, I just want to double check 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. There should be 30 data points. So I'm going to put the video on hold while I enter it so I don't waste your time. So back to the website, I've typed in all the values. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So I should have 30. So I'm going to hit calculate, and lo and behold, I do have 30. So I'm confident that I typed everything in properly. So it says you're analyzing the data. Which battery do you think would be the best buy? Well, I guess I would be interested in knowing what the average is. What's the average lifespan? Well, it looks like it's 5.74 years. So that's for battery X. Okay. And then, of course, for battery Y, I'm not going to waste your time. I've already done it. It is what looks like 5.72 years. Now, battery X, let's see, what is the median? The median is 5.75. That's the middle number. And then the mode is 5.7. Again, without wasting your time, I've already typed in for battery Y, the median is 5.75. and the mode is 5.9. So when it comes to describing which one's the better battery, you have to ask yourself, which battery has, on average, the better lifespan? Well, which data point, mean, median, or mode, would best describe the data? Well, if you sort of take a look, do you have any crazy outliers? Anybody that's pulling the average up or down? So there's a couple of low ones, 3.3, 3.1, 4.3. And then you take a look at this one. They all seem to be sort of centrally located. So which one looks more reliable? Well, because the data points all suggest roughly the same amount of time for all of them, I would have to say that it's this battery. Okay, even though it looks like on average it looks like it lasts only 5.72 years, this one looks like it on average looks like it lasts 5.74 years, but that's because there's just the one or two batteries that are pulling the average up. But if you eliminated those and took the average again, this would be significantly lower. Okay? Hopefully that makes sense. I'm going to go down. It says here, are the measures of central tendency, mean, median, mode the only calculation one needs to make to analyze data? The answer is no. Because you need to look at outliers. You need to consider numbers that shift the average up or shift the average way low. So crazy numbers that are really, really big or really, really small compared to the rest of the numbers. Okay? It says here, are sets of data usually reasonably close to the averages, or do many outliers typically exist? That depends on what kind of data you're looking at. So usually if you take a large enough sample, okay, usually they're close to the average. Are they always going to be close to the average? The answer is no. But the larger the sample, the better the average becomes. Okay? It says here, if most data items in your set are close to the average, what can you say about the dispersion, meaning the range of numbers? Well, if the data set is close to the average, the range is small because all the numbers are close to the average. That means the biggest number compared to the smallest number, if everybody's close to the average, then the difference is very small. But if the, it says here, if they're not close to the average, meaning it says here, what about many data points, many data items are far from the average, then that means automatically the range is very large. Okay? And hopefully that makes sense.